Hi friends, I am Yashwant Kanetkar and today we propose to understand how the Python compilation process works. This is important because the compilation process is slightly different than the compilation process of traditional languages like C or C++. Let's first understand the traditional model and then we'll see this new model that is adopted by newer languages like Java, Python and C#. Whereas the traditional model is being followed by languages like C and C++. In this traditional compilation approach, what is done is your C program or your C++ program is compiled for a particular platform. By platform, what we mean is the microprocessor operating system combination. For example, here we have a Intel x86 microprocessor being executed on, let's say, Windows PC, or machine language instructions created for ARM are being executed on a smartphone. So PC will have its own operating system. Similarly, smartphone will have its own OS. Maybe there is Windows OS installed on your PC, whereas Android OS is present on smartphone. So instructions specific to a platform are created during compilation. Why these specific instructions? Because the instruction set for a particular microprocessor would be different than another competing microprocessor. There would be common instructions. For example, addition, multiplication, subtraction. For these, the instructions are not going to change. But if I am to do, let's say, multimedia operations on a microprocessor, then instructions to get them done for one particular MUP would be different than the one that are used for doing the same multimedia operation on a different microprocessor. So from microprocessor to microprocessor, instruction set is going to be different. Secondly, in operating systems, the way input-output is done by one OS is different than the way it is done by another OS. Similarly, the memory management done by one OS, the approach that is used by another OS might be different. So across microprocessor, there would be differences in instruction set. Across operating systems, there would be differences in input-output method and the memory management method. That is the reason why a program that is compiled for one particular platform does not work on another platform. You have to recompile it and target it towards the other platform, then only the program would work. Means you write the program once but compile it for different platforms multiple times. Each new platform is there, you will have to compile it for that particular platform. When you follow this approach, realize that the final executable that gets created, that is bound to run faster. Secondly, it is difficult to create compilers for each new platform. That becomes the disadvantage. Because there are lots of intricacies involved in this creation of compiler. If a new platform comes along, then creating a compiler for that particular platform is not an easy job. Also, the solution that we are creating through the traditional approach is not portable. I told you why it is not portable, because machine set or instruction set, input, output and memory management is going to vary from one platform to another. That is why program compiled for a particular target platform will not work for another platform. You will have to recompile it, target it for that platform, then only it would work. Means portability suffers when you make use of this traditional approach. Plus point is that the program works faster. Why program runs faster here is something that we will understand when we see the new approach towards compilation that is followed by languages like Java, Python and C#. So let's understand this approach. What is done here is the program that we write is not immediately converted into machine language instructions. Instead, the program gets converted into an intermediate language instructions, which is often known as byte code. So compiler will take Python program as the input and generate the byte code instructions, which are readable instructions. And then these byte code instructions are converted into the machine language instructions on the fly by the Python interpreter, which is often also known as Python virtual machine. That is why I have been insisting that in Python there is a compiler and there is also an interpreter. Compiler does the job of conversion of Python code into byte code, and interpreter is the one which converts from byte code into machine language instructions. Out of these compiler and interpreter, bulk of the work is done by the interpreter. That is why people keep talking that Python is an interpreted language, because bulk of the work is done by interpreter rather than the compiler. Now, by following this approach, do we gain anything? Well, we gain portability. Why? Because the Python program, once compiled into bytecode, the same bytecode can work across Python virtual machines. So for each platform, different Python virtual machines are created, and once they are installed on your machine, any Python bytecode you bring in, it will run on that particular interpreter or that particular Python virtual machine. That is very important, that the same program can work for any Python virtual machine. But in the process of doing this, do we agree that we have introduced one extra layer of PVM? In traditional languages, the program got immediately converted into machine language, whereas here it will have to go through the intermediate layer of bytecode, and since bytecode is interpreted by Python virtual machine on the fly, there is an additional layer involved. So even though we are able to gain portability, it will suffer from the point of view of speed. So it's a really tussle between portability and speed. Based on what is your requirement, you have to decide which language to choose. Goodbye, good luck, and thank you.